Very simple two moves. Starting with 1, you can multiply the number by 2 and add 1, or divide it by 2. Can we reach 2025 using these two operations if you start with 1? That's a very simple idea. So for example, if you start with 1, you can multiply 1 by 2 and get 2 times 1 plus 1 is 3. And then if you do again 3 times 2 plus 1 is 7, then 15. If you decide to divide it by 2, 15 over 2 is back to 7 again. So the number can grow by twice plus 1, and you can divide it if you are overshooting. Is it possible to reach 2025? In decimal representation, this may not seem obvious, but there are not much options, I guess. And the key idea here is when you do 2a plus 1, this operation always adds one binary bit to binary representation of a number. For example, if you take 26, do 2 times 26 plus 1 is 53. And 26, this is the binary representation of the 26. If you do binary representation of the 53, it just adds one byte at the end. And the same way, if you do the division, start with 49, for example, if you divide it by 2 is 24.5, and take the floor of it, and the binary representation of 49 is the following number. 24 just removes the last bit. So using these two ideas, the operations either add 1 to the end of the binary representation or removes the last bit. So if you go back to the initial problem, so you start with 1, you can either add the 1 here, or if you have several digits in binary representation, you can remove the last digit. So the question is, can you reach 2025? Is it possible to get zeros at these locations? Or even if you change the starting number? So what kind of number? So what would be a1 in order to be able to reach 2025?